Welcome to the online class Digital Signal Processing, taught by my colleague Dr. Paolo Prandoni and myself. This is an online version of an undergraduate class that we have taught on various campuses across the world, including Columbia University, University of California at Berkeley, and now École Polytechnique Fédérale de Lausanne here in Switzerland, and we are excited to bring this material online. It is based on a textbook that we have written and that is available for free online, both in HTML and PDF version. You can find the information on the web page of the class. We hope that you will enjoy this material as much as we do. And while there is some mathematics required, well, there is no free lunch. Thanks to the material, you will understand how the digital world clicks as we know it today. And now, let me hand over to my colleague, Paolo, for an overview of the class.
Let's see why digital signal processing is so cool. Take your average smartphone. You can do so many things with it. You can listen to music, you can watch videos, you can take pictures, you can read a book, you can send email, you can find your way around with GPS and maps, you can play games, and of course, you can make phone calls. Now, there are a lot of technological and manufacturing achievements behind such a small device, but the key theoretical aspect that concerns us is that we are able to use the very same device to handle vastly different signals. And that is really the key to digital signal processing. Now, when I use the word signal, I am referring to the description of a physical phenomenon that evolves over time or over space. So for instance, if you think of music, you have a time-varying pressure wave in air. A black and white photograph is the evolution of a grayscale level over space, a space being the support of the photo. And a video is a time-varying sequence of images, so it is a signal that is defined over both space and time. Now, in the past, each signal required a tailor-made processing device. So you had record players for music, cameras for images, VCRs for video, and so on. And then came the so-called digital revolution. So what does digital mean in this context? And to understand that, we just need to look at the root of the word itself, which is the Latin term for finger. Now, when you were a child, you first learned about natural numbers, about integers, by counting on your fingers. And so today, by digital, we indicate something, whether it's a process, a device, or a mathematical model, that only uses natural numbers internally. So a digital signal is a signal that only uses integers to describe a physical phenomenon. For instance, this video you're watching on your PC, well, if you were to take a magnifying glass and look up close, you could see that the images are in fact composed of a countable set of minimal units called pixels. And you could also see that each pixel has a color that comes from a finite countable set, and that these colors change at discrete moments in time. And we could do the same for music. If we plot the data associated to the digital sound, we ultimately reach a level of detail in which we can see the individual atoms that make up the sound, and these atoms are once again just integers. So in digital signal processing, signals that are in fact very, very different physically are all represented internally in the same way as lists of integer numbers. And this is really the great power of the digital representation. Now, the happy coincidence, or I should say the happy convergence, is that in the last 50 years, we have become extremely good at producing machines that can work super fast with long lists of numbers. And these machines are called microprocessors, and they're literally everywhere, including your smartphone. And at the same time, we have become very good at producing very large and very compact storage devices for integer numbers. Think of the terabyte hard disk in your PC or the micro SD card in your camera. And so here we are, we have lots of memory on one side, and we have lots of processing power on the other side. And there are lots of interesting signals out there that we want to listen to, we want to look at and play with. And thanks to the versatility of the digital representation, we can pack and we can manipulate a world of signals into something just as small as a smartphone. And this is really the grand achievement of digital signal processing. And in this online class, we will study why and how this is possible at all. So the course will start from the simple notion of what a digital signal is, and build a self-contained mathematical framework that includes Fourier analysis, digital filtering, sampling, and interpolation. And we will study practical signal processing algorithm, digital communication schemes, and some common compression techniques that we use every day. And we will have many hands-on labs where you will have to write your own signal processing code and develop very cool applications. So I hope to see you back for the beginning of classes, and I guarantee it's going to be a lot of fun.